welcome to this video. We're going to be talking about the derivatives of the trigonometric functions and how to do different problems where we have to take the derivative of them. And so yes, these functions have their own special derivatives, and unfortunate as it is, yes, you will need to have these memorized for the AP test. So what we're going to do is just go over a few problems where we have to take derivatives where trigonometric functions are involved. And so you can see we have this list over here that has all the derivatives, and so make sure that you're really familiar with that because you're gonna want to be able to just know what like the derivative of cotangent is on the day of the AP test. So we're just going to start with an example where we have the function y equals the sine of 2x cubed. And we want to find y prime, we want to take the derivative of this. So hopefully you recognize that on top of knowing what the derivative of sine is, we have to apply chain rule here, right? Because we have an inside and an outside function. Our inside function is this 2x cubed, and our outside function is sine. So it's going to start becoming really common that you have to use multiple rules when you're taking the derivative. So we've identified that we're going to have to use chain rule here. And chain rule says that we start by taking the derivative of the outside function. So we established that sine is our outside function, so we want to take the derivative of that first. And over here on our chart, we can see that the derivative of sine is cosine. So when we take the derivative of sine, the outside function, that is going to turn into cosine. And then the chain rule tells us that we keep the inside function the exact same, and then we multiply everything by the derivative of the inside. So the inside is 2x cubed, so the derivative of that should be 6x squared. So the cosine of 2x cubed times 6x squared is our y prime. So on top of knowing the derivative of sine, we had to also apply chain rule. So we can see this in another example. If we have y equals cosine the square root of 3x, and we want to take the derivative of that. Again, we have a square root and we're doing differentiation. So the very first thing we should do is rewrite the square root. So I'm going to rewrite this as the cosine of 3x to the 1/2 power. Always rewrite things. It's a really good idea. So now we want to take the derivative of this function, this y right here. So y prime is going to be, again, this is going to be a chain rule situation. So that means we start with the outside function. So cosine's our outside function, and the derivative of cosine is negative sine. So we're going to have negative sine, and then our inside function stays the exact same. So we're going to have 3x to the 1/2, and now we need to multiply all of that by the derivative of the inside. So our inside is 3x to the 1/2, and we want to take the derivative of that. So let's work that up here. 3x to the 1/2 is our inside function, and we want to take the derivative of that. What you might notice is that we're actually going to be using chain rule twice here, because the inside function, 3x to the 1/2, this is like another composite function. You can identify this 1/2 as our outside function and this 3x as our inside function. So this is chain rule within chain rule, which will happen. You could have like 10 different layers of chain rule. So if we look at 3x to the 1/2 and we apply chain rule to this, we're going to bring that 1/2 down because we're going to start by taking the derivative of the outside. Inside will stay the same, and then we're going to subtract 1 from the exponent because we were taking the derivative of the outside function, and then we need to multiply all of this by the derivative of the inside. Our inside function is 3x, so the derivative of 3x is going to be 3. So this whole thing right here is the derivative of what our inside function was over here. So really, there were inside functions within inside functions. So this is what's going to go down here. I'm going to multiply that 3 by that 1/2 to give us 3/2, and then 3x to the negative 1/2 power. So this was a situation where we had to do chain rule twice, and that will happen a lot, or you might have to do it more times than that. So make sure you're really careful about and really intentional about recognizing inside and outside functions. So cosine was our very outside function, and then this 1/2 was our next outside function, and then the 3x was the innermost function. So make sure you're careful when you're doing that. Also, a note on the derivative of cosine. As you can see up here in this table, the derivative of cosine is negative sine. So don't forget that negative. That is a very common mistake. So the derivative is a negative sine x. So don't forget to put that negative there. The next example we're going to look at is y equals the secant of x squared. And we want to take the derivative of this. So again, not only are we going to have to know what the derivative of secant is, but this is going to be chain rule because our outside function is secant and then our inside function is this x squared. So if we look on our table over here, the derivative of secant is tangent x times secant x. So when we take the derivative of secant, what it's going to look like is it's going to be tangent of x squared times the secant of x squared. So I want to take a second to note that these are x squareds in here and not just x like you see over here. And this is a super common mistake, and I don't think this function gets practiced enough, which is why this mistake is made. But when you do the derivative of secant, and the derivative of secant is tan x secant x, these x's should be whatever the inside function is. So if your inside function isn't just x, it's x squared or like x cubed or x squared plus 4. If it's something other than just x, that has to go in both of these spots, because really what these x's in this formula over here represent is they just represent whatever your inside function is. So if your inside function isn't just x, that needs to be represented here, because the chain rule tells us that the inside should stay the same, and our inside was x squared, so our x squared had to go in both of these spots. So that's a super common mistake. Be really careful about that. So what we have written right here so far is the derivative of the outside. We kept the inside the same, right? These x squareds are still the same. So this whole piece right here is the derivative of the outside. And chain rule tells us now we need to multiply by the derivative of the inside. And our inside function is x squared, and the derivative of x squared is 2x. So this is our y prime. So secant is a really tricky one, so try to practice a few examples with that. Next, we'll look at y equals the tangent of 6x. And we want to find y prime. So we're going to be using the derivative of a trigonometric function and chain rule, because tangent is our outside function, 6x is our inside function. So first, we got to take the derivative of our outside of tangent, and the derivative of tangent is secant squared x. So we're going to have secant squared, and be careful, this x should be whatever your inside function is, and in this case 6x is our inside function, so that needs to stay the same. A lot of kids they'll see x in the formula and just put down x every single time, but what x really represents is the inside function. So the derivative of our outside is going to be secant squared, and we kept the inside the same. And now chain rule says we multiply by the derivative of the inside, and the derivative of 6x is just going to be 6. So secant squared 6x times 6 is our y prime. The last example I want to look at is if we have y equals cosine of 4, and we want to find the derivative of this. And you might already see, it might be obvious to you, but for some reason this kind of trips people up. So the reason why is because I think a lot of people, they see this cosine and they immediately go, okay, the derivative of cosine I know is negative sine, so I'll do that and I'll do the whole chain rule. But this one is a bit tricky, because hopefully what you realize is that cosine of 4 is just a number, right? You could plug that into your calculator and it'll give you some decimal. And so what's the derivative of any number, any constant? Well, the derivative of any constant is just 0. So y prime here in this case is just 0. So that's a bit of a tricky one, because I think when we see these trig functions or any log functions, you immediately want to jump to one of your derivative rules. But notice there is no x in this term. So this term is just a number, it's just a constant, and the derivative of any constant is just 0. So be careful with ones like this. They will come up occasionally, and they definitely tend to trip some students up. So make sure that you're trying to recognize when a function is really just a number, it's just a constant, and you can just say its derivative is 0. So hopefully these examples were helpful, and if you have any really tricky problems or examples that you want to see done, make sure you leave those in the comments, and don't forget to subscribe.